Hey, this is Charles with Rocky Mountain ATV MC, and you're watching part 2 of our top end rebuilding series for the KTM 690 and Husky 701. And in this video, we're going to show you how to tear down the top end and inspect those parts. First thing on the engine, what we're going to do is remove a couple of these hoses out of the way. So I'm going to start with this thermostat housing, and rather than cut this band down here, I'm going to leave it on the housing just so we can remove the whole thing at once. And I'm going to pull this thermostat out at the same time. Next, we're going to remove this upper radiator hose. And now the crankcase breather. Now we can remove the valve cover. I recommend removing your spark plugs now as well, even though we're removing ours in a later step. The next step is to put the engine at top dead center on the compression stroke. So to do that, we need to gain access to the flywheel bolt. So we'll go ahead and remove this plug. Now to get to top dead center on the compression stroke, we're going to rotate this flywheel bolt counterclockwise until we see the intake valves open and close. We'll keep rotating until we see the line on top of the camshaft line up with the line in its holder. Next, we're going to remove the 4 smaller bolts on top of the cylinder head. And the front 2 bolts, when you remove those, you can screw them into those shafts to remove them. Now as you remove the shafts, it's going to free up the rocker arms. So you can take all this and lay it out in order on the workbench. And the other thing to pay attention to, make sure these shims didn't stick to the rocker arm. Next, we'll use a magnet to remove these shims, and we're going to lay them all out in order. That way they get returned to their original positions. All right, the next step is to release our cam chain tension. So what I'm going to do is crack this bolt on the back of the tensioner loose, and then I'm going to remove the tensioner. And then we'll pull that tensioner out. All right, now with the cam chain loose, we have our cam retainer. We're going to remove the bolt from that and remove the retainer. Just be careful you don't drop this into the bottom end. And now that I've pulled the camshaft out, I'm going to take this chain off, work it towards the motor side. And I'll raise it up, and then we can remove the camshaft. And this cam chain, I'm just going to drop it down in there. So at this point, we need to completely remove these 2 screws right here and just loosen this lower one up. And then these 4-cylinder head bolts on top, we're going to loosen these up in a couple of different steps in a crisscross pattern. Now we'll go ahead and remove all of those bolts and remove the cylinder head. Now if the cylinder head sticks on, you can use a soft face mallet to help tap these sides and break it free. Now before we remove the cylinder, it's a good idea to remove the starter motor just to have it out of the way. So I'm going to loosen the second bolt. And if you watched the first video, that's when we loosened up this first bolt. So this thing, it might be in here kind of tight. You're probably going to have to rock it free. Now to get the cylinder all the way off, we're going to finish removing this bolt on the side. Now that the cylinder has broken free, We're going to raise it up just enough to expose the circlip on the piston. Before we remove that circlip, what we're going to do is stuff some rags into this bottom end, and that way we don't drop anything down in there. And then I'm going to flip the motor around and pull that circlip from the opposite side of the cam chain. The next step is to remove our wrist pin. So to do that, sometimes you can push these out with your finger. If you can't, then you're going to need to use a piston pin puller. So this one comes with a couple different adapters to fit whatever piston you're working on down here on the bottom. So we've slid that into place, and then it also has a couple of different collars that go on the ends for different sizes of wrist pins. So you want to select the correct ones, and then we'll install the tool through that wrist pin. You also want to apply a little bit of grease to the threads and the collar of the tool. Once the wrist pin is all the way through, you can remove the tool and remove the cylinder. All right, next we'll remove this base gasket. Now with the rags out, if you're just doing a top end on this motor, then you're going to want to inspect your connecting rod and make sure that everything's okay with it. So when you're in here, what you want to do is make sure there's no up and down play. So if I pull that up and down, this one's actually solid. You also want to check the small end for any pitting or scoring inside of here. And if this part is damaged, then you're going to need to go in the bottom end and replace it. If you need more information on inspecting the connecting rod, we do have a video just on that. Next thing, to inspect the cylinder on this, what we're going to do is remove our piston. So I'm just going to pull this out of the cylinder. And you can see on this piston, if you have regular signs of wear like this, then the cylinder is probably going to be okay. But if you have some really deep grooves in this or any visible damage, then there's a good chance that the Nicosil coating on your cylinder is damaged as well. Now you can visually inspect the cylinder for any damage like scuffing or deep grooves. A good test for this is to run your fingernail over the plating, and if it catches on anything or if there is any pitting, then you need to recoat or replace it. If it looks okay, then we'll clean it up with a hone. Now to hone your cylinder, if you're not familiar with the process, refer to our how-to video on that. It'll guide you through it. All right, now for the measurements on the cylinder, we need to make sure that this isn't warped where it mates with the cylinder head. So we're going to take measurements in 6 different directions, and the service limit for warpage is 0.4 of an inch or 0.1 millimeters. So we're going to start with that feeler gauge, and we're using our straight edge just laid across the cylinder to check this. If it goes through at any point, you want to try going one size larger. If this measurement exceeds the service limit at any point, you're going to need to replace the cylinder. All right, the next thing we're going to do is measure the cylinder bore. Now, to do that, you're going to find out which cylinder you have. So on top of the cylinder, right where this cooling passage is, you're going to have either a 1 or a 2 stamped in here. Ours is a number 1. So the size on this is going to be 4.01574 inches to 4.01621 inches. And if it doesn't fall within that spec, or if we have a lot of taper or it's out of round, then we're going to want to recoat this Nicosil plating or replace the cylinder. Now size 2, you're going to be 4.01625 inches to 4.01672 inches. Now to measure the inside diameter of the bore, the best tool for the job is a dial bore gauge. But if you don't have one of those, you can use a snap gauge to do that as well. So to use this tool, I'm going to let it snap out against the cylinder, kind of let it settle in there. I'm going to lightly tighten it down. And right now I have the gauge longer than what the cylinder actually is. I'm going to rock it back and forth and try to find the center as close as possible. And then I'm actually going to push this through and try to rock it back and forth. And it's going to center itself in the middle of the cylinder. And once I push it through, I'll tighten this thimble down all the way and then measure this with the micrometer. Now when you're using a snap gauge, you want to measure the same spot a couple different times until you start getting the same reading every time. And that way you know you're getting an accurate measurement. So all of our numbers fall within spec, so we're going to go ahead and reuse our cylinder. The last inspection we're going to make on the cylinder is to check that O-ring that sits where this cam chain tensioner normally rides. Make sure that's in good condition and replace as necessary. The other gaskets we will be replacing no matter what. Except for the valve cover gaskets, these can be reused if they're in good condition, so check them for any damage or tears. And same thing with these 4 seals on top. Now, if you're not going to be in here in the near future, then you definitely want to just get them all replaced while you're in here. Now moving on to the cam chain, we have ours out since we're doing a bottom end rebuild on this engine as well. But if your cam chain is still on the bike, how you can inspect that is pull up on it and just kind of roll it around like this and then let it straighten out. When you let it straighten out, if you have any kinks in the chain, then you know it's bad and needs to be replaced. You also want to look at the individual links and check for damage there and replace as necessary. Now before we inspect any of our parts, we want to clean them up with some contact cleaner, and on some of the gasket sealing surfaces, we're going to use just a little bit of Scotch-Brite. Now moving on to the other valve train components, we'll look at this camshaft first. So we have the cam sprocket. You want to make sure none of the teeth are broken off, and the teeth should also have a uniform pattern. If it shows more wear on one side than the other, then it's bad. And if you had a bad cam chain that was binding up, you probably are going to have to replace this sprocket as well. So now onto the auto decompression mechanism. So if I press out on the weight, it should make that little hump that's on the back of the cam lobe. That should go away and it should show a flat spot. If I let go of that, the weight should spring back and the hump should come back. If it doesn't do that, you want to make repairs or replace any broken parts like this spring. Other than that, you'll want to inspect these bearing surfaces where they ride on the bearings that are inside the cylinder head. Make sure there's no deep grooves or pitting. And we're also going to measure the cam lobes. We'll measure the height with a micrometer. Now, if these are out of spec, or if you see any obvious visible damage to them, like if these are pitted or grooved, or maybe the ends are kind of mushroomed out and you can see that the lobes have actually worn down, then you're going to need to get this part replaced. Next, we're going to look at the cam chain tensioner. So main thing with this, you want to make sure that the spring is still good and it's not broken. So with this, to make sure it works correctly, what we're going to do, we're going to press it down and make sure it releases and pops back all the way up by itself. And this one does. So if it does that and these surfaces are smooth and there's no damage to this tip, then you can obviously reuse this. So once you've done that, we're going to set the installed height of the tensioner. And to do that, there is a measurement, but we're just going to make the job quick and easy. And we're using a nickel and a dime. That's going to be the correct height to set this outer sleeve down on the inner sleeve. So I'm going to press this down. And once you're at that height, it should stay down like that. So you can see where the color changes. You're going to have a little bit of silver and then it's a darker gray. That's exactly what you want. And if it doesn't stay down like that, try it again. You might have gone too far, but if it never stays down like that, then this piece is bad and you want to get it replaced. Now, if you don't have a nickel and a dime, you can use just a couple washers that are going to be about the same height. Next, we're going to move on to the rocker arms and the rocker arm shafts. So this is one of the weak points in this motor, and it's usually with this roller. These can wear out over time, and if they are worn out, you're probably going to notice a lot of free play in your valve lash when you take that valve cover off initially. If they're bad, you would be able to move this roller up and down, which ours is on there solid. And the other thing, you want to check for pitting or any deep grooves on the roller itself. So you can see there is a line in this, but if I run my fingernail across it, I can't even feel it, so I'm not worried about it. And we're going to be reusing this part as long as this inside diameter looks good. So this runs on the shaft. So let's talk about the shaft first. I'm going to do the same inspection, take a fingernail, I'm going to run it across there. If I feel any grooves that my fingernail catches on, then this thing is worn out and you want to replace it. If this is worn out, chances are this rocker arm is worn out as well. But this one, you can see, you know, it's been running on here. It has some witness marks, just meaning that, you know, you can see it's been in use, but it's not enough wear to where you can actually feel it. So I'm going to slide this in place. If I was to rock this back and forth on the shaft, if I tried to rock it side to side and felt a ton of free play in there, that would be another indicator that this piece or both pieces are worn out. So ours feels good. The last thing we want to check on these rocker arms is the pads on the end. So you want to make sure it's a round arcing surface right here on the end. If it's flattened off, then you know these pads are worn down too far and this piece needs to be replaced. Now moving on to the piston and wrist pin. Most of the time when you're in here, you will be replacing your piston. This is going to come with the rings, your wrist pin, and the circlips. So you shouldn't have to mess around too much with measuring this. But on this piston, if you only had a transmission issue and you did a compression and leak down test on your engine before you tore it apart and all this checked out okay, you'd want to leave this piston inside the cylinder, only remove one circlip and pull the piston pin out. Now you do want to inspect the piston pin for wear or damage. So if there's any grooving on it, or if it looks worn out, or there's any pitting on top, then you want to get this piece replaced. If that's the case, you might have to replace the piston and connecting rod as well. Moving on, you can take a measurement on the piston, but most of the time you would actually be doing this with the new piston if you wanted to figure out your piston to cylinder wall clearance to make sure that's in spec. So I'll show you on this old one. We're taking the measurement 31.5 millimeters from the top of the piston at a 90-degree angle from the wrist pin with a micrometer. You want to check your manual for the correct specs on your engine. So you just take that measurement and subtract it from your largest cylinder wall measurement, and then you have your piston to cylinder wall clearance. So from that point, we'll go ahead and move on to the cylinder head inspection. Now with the cylinder head, the first thing we're going to do is do a solvent test to make sure our valves are sealing correctly. As you can see, our cylinder head, it's already dried off. If yours is wet from coolant or has some oil on here or whatever, you want to spray that off with a little bit of contact cleaner and start with a dry surface in the combustion chamber. I'm going to remove this rubber boot just so I don't get any solvent on it. And then from here, I'm going to tip the cylinder head on its end, and I'm going to take some solvent and actually pour it down the intake ports. I'm going to fill this up, and we're going to let this sit for a minute. Once the valves are completely covered, we'll let it sit, and you're going to check for any leakage around these valves. So you can actually see this one on my right, this one's getting a little bit of moisture, or it's a little damp around the edges. So it doesn't have a terrible seal, but it's not sealing perfectly. So we're going to want to inspect that and make any repairs that we need to do to get that sealing correctly. Next, we're going to clean up any solvent that came from this intake side, and we'll do the same test for the exhaust side. So this side isn't showing any leaks, so we know the sealing surface should be good, but again, we're just going to inspect everything while we have this apart since we're already concerned about this intake side, and we want to get those valve guide seals replaced. Next, we're going to clean the sealing surface with a gasket scraper and some Scotch-Brite and a little bit of contact cleaner, and then you can also use some carbon remover inside this combustion chamber, let it soak for a little bit, and then wipe it out to help clean up this combustion chamber. So obviously we still have some work to do to get this cleaned up, but We just kind of want to show you the process. I'm actually going to go ahead and continue with disassembly, and we'll soak some of these parts a little more to get the rest of that carbon off. Now to take the cylinder head apart, what I like to do is put a punch in the vise, and then one of these holes for the cylinder head studs, we'll just slide the punch down in where that goes. And then the cylinder head's going to rest just like that. Makes it really easy to work on everything. The other thing I want to point out is if you look at the bottom of these valves, they're kind of round. Sometimes there'll be a little dot in the middle, and that's going to determine which part of your valve spring compressor you're going to use. So we have this rounded side on bottom. So I'm going to start with these intake valves. We'll center the compressor on that valve, and then we'll tighten the tool down and remove the keepers. And when you remove these parts, it's very critical to keep everything laid out in order. So we have this spring retainer on top. The spring, obviously the fat side goes down. Next, we're going to press the valve through, but what I like to do is press it down just a little bit, and I'm going to grab the valve face with 2 fingers and try to rock it back and forth, and that's going to let you know how much wear has really happened to that valve guide. So this one rocks just a little bit. If it rocks a little bit, it's fine. If it rocks a lot, then you know it's really worn out, but we are going to take measurements on these parts to verify any wear. Next, I'm going to remove the valve stem seal, and I like to use some needle nose pliers. Just lightly clamp on it and pull it off. That spring seat didn't want to come off, so sprayed a little contact cleaner up in there to break down that oil. Now once you've done one valve, you'll do the same steps to the remaining valves. And again, just make sure you keep everything in order. Now that the valves are out, we're going to inspect our camshaft bearings to see if they can be reused. So what we're looking for here, it's the same as any needle bearing inspection. You want to check for any flat spots on these needles or any pitting. You also want to check that cage inside of there and make sure that there's no broken spots. So these ones, they don't look terrible, but you can see they're worn down a little bit. So we're actually going to replace both of these bearings in the cylinder head. Now to do that, you can heat up the cylinder head with a hot plate or use a heat gun to warm these areas up. And then KTM actually has some special tools to remove these, but in our case, we're actually just going to use a blindside bearing puller. So now we'll take our blindside bearing puller and tighten it down. Then for this outer one, I'm just taking this 40mm collet and I'm just going to hook it under the first lip on this outer race. Now that the bearings are removed, we'll remove both spark plugs and our exhaust gasket. So at this point, we're going to go ahead and finish cleaning all the carbon from our cylinder head and the valves, and then we'll start taking some measurements. Now that we've cleaned everything up, we're ready for our measurements. So I'm going to start with the springs, and I'm just using a digital caliper to do this. The minimum spec on these springs will be 42.3 millimeters or 1.665 inches, and we are above the spec. So this one's looking good. Now moving on to the valve. Most of the problems with these valves, you can do a visual inspection and find them. So on the very end, you want to make sure this tip isn't mushroomed out. And then moving down to the valve face, right here you want to make sure this isn't cupped out, kind of like a U shape. If it is, you want to replace it. This surface should be straight across. Now the other thing that can happen is if you suspect a bent valve, usually it's going to be obvious, but if you're not quite sure, you can use some V-blocks and measure the run out on this valve face with a dial indicator. Refer to your manual for this, or you can chuck these up in a drill and check for any wobble. Now moving on, the spring seat, you just want to check these, make sure they're not cracked or visibly damaged. Same with the retainer. And then we have these keepers. You want to keep these with the valve that they came off with. Make sure there's no visible damage on those as well. So now that you know what to look for, you'll do the same inspections for the other valves. Now moving on to the cylinder head, we need to visually inspect this for any cracks or damage and pay special attention to these valve seats. These can actually chip, so if they're chipped, you either need to get these seats repaired or replaced. Now if you don't see any visible damage, even by these valve guides, then you can take the valve that matches with the valve guide and rock it side to side. If you can feel a lot of play in there, then chances are you're going to need to have the head machined or replace the whole head. That valve guide's probably worn out. Now, a better way to check that is with a small hole bore gauge. What we're going to do is set a micrometer to the service limit, then we'll adjust this to that limit and try to insert it into the guide. So this gauge at the service limit won't go into any of the valve guides, so we know they're all good and we can reuse them. After that, we're going to check this cylinder head for warpage, and we're going to check it in several different places. And the service limit is 0.4 of an inch, so just make sure that your straight edge is square against the surface. And if this goes in at any point, you know it's warped and the surface needs to be repaired, or you can replace the head. Now we're going to check the contact pattern of the valve face with the seat on the cylinder head. So to do that, you can use a Sharpie and just color that surface, or the easiest way to do this is use a little bit of Prussian blue. I'm going to use the Prussian blue. What we can do is insert the valve into that valve guide that it normally goes in, and you're going to apply just a little bit of this stuff to the valve face. It's really thin coating. So I've got quite a bit towards the top, but just on that face, that's about what you want. And then we're going to make sure we don't rotate the valve when we do this. And I'm just going to press it down. I'm using a finger on the other side of the valve stem. I'm going to press this straight down a couple times. And that's going to tell us exactly where our contact pattern is. So you can see where the valve face is actually touching, and you want to measure the width of that with your digital calipers and then compare that spec to the service manual. Now for our valve seats, all we had to do was remove all of the carbon buildup from the valve and the valve seat, and it sealed just fine. The other things we're looking for is a smooth, consistent pattern all the way around the valve face and on the valve seat. And then if this width is too wide, too narrow, or if it's sitting too high or too low on the valve face, then you need to get that valve seat machined. Then we can go ahead and make these same inspections on the other valves. And that's it for disassembling your top end and inspecting the parts. If you need any of those parts, be sure to check out the OEM diagrams on our website. And if you need to know how to reassemble this top end, follow us over to the next video in the rebuild series. And if you haven't already, make sure you subscribe to our channel because you'll find other helpful content on there, including videos like the bottom end rebuild series. So again, be sure to check that out. I'm Charles. Thanks for watching.